we are doing some trig equations. So I got a little, I know, note to self here, but note to you as well. If you ever try and solve an equation and it ends up looking like this, the sine of theta is 0.1, the sine of theta is a half, the sine of theta is whatever the number happens to be. And the general solutions will be theta equals, whatever the solution is, plus 2 pi k. So if you get two solutions, you're going to have two numbers here, both of them with an extra plus 2 pi k. And that 2 pi k essentially generates all the solutions in the universe. And if you're doing a cosine, it's pretty much the same. And if you're doing a tangent, it's pi k. So we have mentioned that. It's just a kind of note to myself, make sure I don't forget. Now, there is a little bit of a decision about what I've called the solution here. If the angle is in the unit circle, so if you get things like sine of theta is a half, or cosine theta is root 3/2, you know those ones are in the unit circle, right? So you should actually be using the unit circle. But when you get things like sine of theta is 0.7, right? Then won't you go to Desmos and find all the answers that way, right? So that's essentially, so there's a little bit of difference about what these look like. If that number's not in the unit circle, then this is just going to be a horrible decimal plus 2 pi k. If it is, it's going to be pi/3 plus 2 pi k. And we'll start with question 4. So we have cosine of theta plus 1 equals 0. And we're going to use that as long as you do it to both sides situation. And we got that guy. That guy, I recognize, is a unit circle answer. Agreed? Right, there is an angle in the unit circle. We are looking for an x coordinate of -1, aren't we? And so in this particular case, theta would be equal to pi. But since we want all the answers, don't we do that? Agreed? Well, that's it. That was the answer. There wasn't a lot to that question. So if we move on to question 5, we're going to be looking at, and I think some of these could well be déjà vu, but that's okay. We do a couple overlap. It's not going to kill anything. Right. If you want to solve a quadratic trig equation, as long as everybody's cosines or sines, it's a quadratic, you will take this guy, and 2 cosine theta gives me 2 cosine theta and a cosine theta. And it's essentially solving this. Right. If I went and said to you, factor that, I hope you would say, it's not too bad. 2x squared gets me 2x and x. I need to have two numbers, 1 plus, 1 minus. If I put the +1 here and the -1 there, everything comes out. Do you agree that's how that would work? Factor, you've got. So that's like 2x squared, take away an x, add 1. So we are looking at two numbers that multiply by 1. Since this is going to be negative, that is the combination that works. And to check that it works, shouldn't you really FOIL it out to make sure you got the right one? Because it could be back to front. But that's all you've got, right? Two choices. One of them's right, the other's wrong. You're going to figure it out. Now, once you have factored a quadratic trig, you then take each one of the factors and make it equal to 0 and solve. So in this case, take a 1 away from both sides and then divide by 2. Is that angle going to be in the unit circle? So I nip over to my unit circle and I find an x coordinate of -1/2 and I get 2/3 pi. And if I look a little bit harder, I also find another one down here somewhere, 4/3 pi. And since we want all possible solutions, don't we add that plus 2 pi k thing that we were talking about? Okay, so that counts as 2 of my solutions, right? So far, so good? Right, now you take this factor and you find out what makes it equal to 0. And this time you get the cosine of theta is 1. And that is also on my unit circle. And we use 0. They have that little 0 theta less than or equal to 2 pi thing going on, right? So basically you use 0 and you don't use 2 pi. So I have an angle of 0 plus 2 pi k. And when I add it onto my list, you don't write the 0 because there's no point. You know, agree 0 plus 2 pi k is just 2 pi k. And those 3 guys count as my solutions. And when you do them in the WebAssign way, they give you this bit and you put in a list. And I think they want them in order, but if they do, then it would look something like 0 plus 2 pi k, 2/3 pi plus 2 pi k, and 4/3 pi plus 2 pi k. Are we comfortable? Yes.
Would pi plus 2 pi k be 1 too, or no?
If we did pi, the cosine would be -1, so that one wouldn't.
Oh, negative.
That one wouldn't.
Okay. Yeah. Thank you.
Most of the time, don't you get 2 answers like those 2?
Mm-hmm.
But occasionally there are trig situations where there's only 1 answer, right? Theta can only be this angle and that's it, which happened here. Are we getting a little bit of a theme for these? The best way to do these is to get used to the process, right? Oh, you do this, then you do that, and so on. Right now, we've been getting answers that are all in the unit circle, which is great because it's quicker. But, you know, there are going to be some that don't quite turn out that way. But right now, the next one's going to be fine. And then we'll show you, what do you do when you get one of those, you know, cosine theta is 0.1 situations, right? Where you have to use decimals. But let's get one more of these other guys out the way first. Question 6 is the sine of theta 2 cosine theta plus 1 equals 0. Now that's great. They factored it for me. Isn't that nice? Made my life easy. If they hadn't factored it for me, the question might have looked like this. And if the question started life as this, wouldn't you pull out a common factor and make it that guy anyway, right? Right, take out a common factor of sine theta, and this is what you get. So we're going to have 2 situations. The first one is the sine of theta is 0. We know that's on the unit circle. I'm looking for a y coordinate. Right? I'm looking for a y coordinate of 0. So that's what 0 counts. And is there another place on the unit circle where the y coordinate is 0?
Pi.
Okay, over here. And then remember to add the 2 pi k's because we want all the solutions in the universe. So there's 2 of our answers. And on the other side, we have 2 cosine theta plus 1. A lot of these questions, there's only so many combinations in the world, so a lot of these questions end up looking pretty much the same. Would you agree that looks like a couple of examples that we've done in other places? So we are looking for an x coordinate of a half. And that is deja vu, isn't that? 2/3. And the other place where the x coordinate of half is down here, and that's 4/3. I remember seeing that in an earlier question. And then just add 2 pi k's. And so there's your third answer, there's your fourth answer. Okay, nothing too scary. So let's make it just a tiny bit harder by giving you answers that are not in the unit circle. At least one of them is not going to be in the unit circle. Actually, it looks like it's going to be both that are not in the unit circle. So here we go. Question 7 is 3 sine squared theta, take away 13 sine theta, plus 4 equals 0. This is a quadratic trig equation. It's like 3x squared, take away 13x, add 4, right? It's just the same kind of look. Mathematically, very similar to what I just said. Now, since this is, there's Chloe for you. Since this is 3 sine squared, I'm going to call it 3 sine theta and sine theta. Now, this number is 4, so I want combinations of 4. Since this middle guy is 13, that tells me that both numbers are positive or both numbers are negative. But since this is negative, I know they're both negative. So what combination of 4 do you put here and here? Two numbers that multiply by 4, and if you FOIL it out, you get this guy.
Wouldn't it be 1 in the first bracket and 4 in the second bracket?
Let's check it out. 3 times 4 gets you 12. 1 more gets you 13. You have nailed it. Would you agree? Now, I'm going to do this one before that one. Chloe, shush. Chloe. Actually, that's Bailey, I should say. Okay, we have the sine of theta, take away 4 has to be 0, which means that when you add 4 to both sides, you get that. Lots of exclamation marks. Would you agree that that is impossible?
Yeah, it's greater than
There are no angles that are ever going to give you a sine of 4, which means there is no solutions out of that piece of the puzzle, right? We're not going to get any solutions. Now we'll focus on this one. Well, we have 3 sine theta, take away 1 equals 0. That gets me 3 sine theta, add 1 to both sides, which now gets me the sine of theta is a third. And hopefully you can look at that and say, it's not a unit circle answer. You agree there's no 1/3 anywhere, which means it's Desmos. So I'm setting up Desmos and let's go hunting for our answers. And we're only interested in the answers in the unit circle, right? So I only need to worry about 0 to 2 pi. So I may change my windows a little bit to accommodate that. So what's happened there? Oh, oops. There we go. So I'm going to do y, I'm going to do y equals the sine of, if you just type in theta, you get the symbol. And I'm then going to type in y equals 1/3. And I'm going to go over here and I'm going to say, let's just do 0 to 2 pi. And the y values, just so make it a little bit easier to see, I'm going to do a y value from -1 to +1. So I'm just adjusting the windows to make my picture a little bit cleaner. There, can you pretty much see everything that we need to see, right? If you think you need to see a bit more, you can just move your mouse. Now, that's the guy I had, right? So there are 2 solutions here, and the other one is here, right? there are lots and lots of other solutions. If I brought this out, wouldn't you see that line being intersected tons of places? But if you only do 0 to 2 pi, right, 0 to 2 pi, there's an answer at 2.802. And there's an answer at 0.34. Now, if you zoom in on this guy and you click on him, I've been told that you get a more accurate answer. You remember yesterday I had to do the TI-84 and I don't like using it because it's clunky, because it only gave me 3 and I needed more. Just zoom in and you get a little bit more detail. So that's 3398 now. So 0.3398. And I'll leave the other one. So you've got 2 answers, as accurate as you need to be. And I did them using Desmos. And that answer, you then add a 2 pi k to it. And this answer, you then add a 2 pi k to it. And I think, let me check. Oh, I was more accurate than they wanted. I should have looked at the question. They wanted that answer, and they wanted that answer. I think WebAssign can ding you for that, don't they? Have you ever done the correct answer but too much decimal places and it says you were wrong? Is that happened? Right, so, you know, if it wants 10 decimal places, give it 10. If it wants 2, give it 2. I'll open the door. I might let my dog in because now he's barking because he can't be in. Right. The joys of teaching at home. Do you think I should just give my dogs away for medical experiments? Would that be a good idea? No. You know, if I even mentioned that to my wife, I think it'd be a divorce case coming. I love them as well. I know they're pains, but we do love them. Okay, so question 8 is another quadratic one. I'm not going to do that. You've done enough quadratics. So here's a new guy. What do you do if you get a trig equation that uses secants, cosecants, or cotangents, right? The guys that are not in your unit circle, right? Unit circle's really not designed well for those things, right? Well, let me show you my approach. I'm going to add 4 to both sides. I'm going to divide both sides by 3. Are we good so far? I'm then going to take the square root of both sides, which really means I get 2 answers. I get a negative, that guy, and I get a positive version of that guy. So let me rewrite the negative one first. And I'm going to make him pretty. I'm going to do style points on him. Are you comfortable about a square root can be separated as a top of a bomb? And then I'm going to call it -2 over root 3. And then I'm stopping. I'm not going to do any more style points. I don't want to deal with cosecants anymore, or secants, or cotangents. I want to deal with sine, cosines, or tan. if the cosecant of theta is this fraction, what fraction will the sine of theta be equal to?
√3/2.
You remember the reciprocal property, you know, the husband and wife, one's the upside down version of the other, right? You see that it took me a while, but haven't I got to the place that I can now use the unit circle? So I'm looking for a y coordinate of -√3/2. So there should be a y coordinate down here, and -√3/2 comes out to be 4/3 pi. And there's another one, isn't there, over here at 5/3 pi. And then you just add the 2 pi k and the 2 pi k's. So that's us got two of the solutions. You comfortable with that? Right, let's go the other side. Well, isn't the other side going to look exactly like that with one little difference? Would you agree it's just going to look like that when I'm finished? So I'm not going to write all the work in, right? You know, if I did the positive one, wouldn't it look just like this working, and you'd end up with just a positive guy? So I'm looking for two places where the y coordinate is positive, and that's at pi/3. And the other one is going to be 2/3 pi. So there is your four solutions. Can you imagine you could do that same question with 3 secant squares or 3 cotangent squares, right? You could do it with any one of those 3 situations. Agreed? 3 secant squared, right? Basically go through it and then turn the guy upside down to get one of the sine or the cosine or the tan. Depends on the question. Are we good? Any questions? Another one like that. Suppose I give you secant square theta take away 4 is 0. That's the guy, the trig equation we're going to solve. Anybody tell me what the next line should look like? What would I do to get whatever's going to go here?
It'll be secant squared equals 4, and then you square
Great.
root.
So we agree to add 4 to both sides. And then if I take the square root of both sides, don't I get plus or minus 2? So there's 2 distinct situations. The secant of theta is 2. Well, let's say -2 because it looks better. And the other situation is going to be over here. It's going to equal 2. I don't want secants equal to anything, agreed? I want sines, cosines, or tangents equal to anything, right? So how could I rewrite that using one of our 3 main trigs, right? Either the sine, a cosine, or a tangent. So if the secant theta is this, what's my next line going to look like?
Wouldn't the cosine equal -1/2?
Agreed. And this one, the cosine theta equals 1/2. Does that make sense to you, the reciprocal, right? If you know a secant, don't you know a cosine, right? Because if you turn that guy upside down, if you need another figure, does that help seeing it upside down? Right, 2 becomes 1/2. Right, I'm going to stop here. Can't you just do the unit circle stuff in us 2 pi k here? There's nothing, once you got to there, it's pretty straightforward. Are we good? Next couple are trig ones that I'm not bothered about because you've done things like this. Let's jump to 13 because we're on a kind of theme here. Oops, well, let's try that again. Doesn't look like a particularly scary one. I want to solve when is the cotangent of theta plus square root of 3, when's it equal to 0? Okay, as long as you do it to both sides, it's okay, rule. So how about subtract root 3 from both sides? Now, if you know what a cotangent is, you should be able to figure out what the tangent is equal to. Any takers? What's the tangent going to be equal to?
3/3 negative.
Agreed? That one? Right, that is in my unit circles. Tangents typically a little bit harder because don't you have to divide the y coordinate on the top with the x in the bottom, and it looks like that. But the easiest way for me to do it is just cover up the bottom. Right, that's 1 over root 3. In fact, none of them are any good because they all positive. So let's try over here. If you take the y, which is the second guy, right, over the x, you get root 3, not. There you go. You see that one would be 1 on the top and root 3 in the bottom. Agreed? 5, 6. Are we good with that one? What do you add to get the infinite solutions?
See you later
Pi
today.
k.
Pi. I hear that. Pi k? Not 2 pi k, but just pi k. Is there anywhere else on this unit circle where you would get, say again?
11/6 pi. Yeah.
Yeah, that's one here. Now, I don't like what WebAssign's doing, and I would definitely argue with the guy who did it, but let's talk about this. Here is the answer I like, and they have that one, and I have no problems with that. If you add multiples of pi, if you add 1 pi, 2 pi, 20 pi, that's what that does, right? It adds and subtracts pi's, right? If you add 1 pi to this, don't you get that one? So there's no need to have this one if that one has all of them anyway, right? And you just duplicating it, you're just saying it's this answer and it's this one, but this other one's really just the same answer as the one you would have got with the first guy. There's no point to doing it. But they put that blinking guy in, which I don't like, because if you don't need it, you shouldn't. But that's me just grumpy because I'm in a bad mood today, probably. And to add insult to injury, not only did they put an extra one in, they didn't even put that one in, which at least I would have a fighting chance of saying, I take it back. I was looking at the other answer. They did what I wanted. They only gave this one. And I was ranting and raving saying you didn't, because the question underneath it was very similar and I had the second answer. So I'm going for the sympathy thing here. I do that a lot. So here is my sympathy explanation. If you've had me before, you know this one. I wear glasses, not just because they make me look cool, but because I have a really bad left eye. In fact, I'm essentially blind in the damn thing. So if I cover up my good eye, which is my right eye here, I know that when I do that, it might not look like it's my right eye because of the camera switch and everything, but it is. So my right eye is my good eye and my left eye is useless. So if I cover up my right eye, I can't read that. In fact, if you wrote an A the size of that piece of paper, I couldn't tell you it was an A. I could tell you there were some straight lines in it, but that's about all I can see. Now, if any of you've got a really weak eye, as I have, one of the hard things for us is scanning, which means if I look at something and then I turn my head away and I look again, it's not uncommon for me to look at my computer over here, which has the questions in it. And I look at the question and then I talk to you this way, right? And then I look back there and I scan to the next question. So sometimes I write a question down and then the next line is from the next question. So I do a bit of 2 questions. So how does that make my life interesting? I have never seen a 3D movie in my life. I'm incapable of seeing them. I've been to them with my wife because she wanted them. You know, you wear the little glasses. I don't see 3D because you need 2 eyes to see 3D. So I don't know what 3D TV looks like or 3D movies or whatever. So don't you feel sad for me? Or is 3D not that big a deal?
You're not missing out on anything.
I'm not missing it. Good.
Yeah.
No, they give you a headache. Chris.
Yeah.
So what it does, just gives you a headache. So
Yeah,
I'm
after
lucky
an hour
on
in.
that one. What else do I do? I miss door handles because depth perception is difficult with one good eye. To get depth perception, you kind of need 2. So I will, when I'm in the college, will happen from time to time. I'll go to a door and I'll try and turn it, and all I do is grab air, which I don't mind too much. That just looks silly. But sometimes I misjudge it and I hurt my hand because I bang it into the door because I think it's closer, right? So that's not fun. Parallel parking is interesting.
Yeah, you should watch out for him in the parking lot. It's kind of scary.
Okay, that's not nice. Right. Playing any sport that involves a spherical object moving is a mystery to me. I love football. I'm absolutely hopeless at it because I would take a swing at the ball and it wouldn't be there, and it looks really funny when you do that. Tried golf. I knocked more lumps out of the grass than I ever did hitting the golf ball. I've never really did a lot of other sports except, at school, and every single one of them I was hopeless at. Because you do need 2 eyes, don't you, for coordination and knowing where the object that you're trying to catch, hit, or throw is. So do you all feel sad for me now when I screw up and I moan about how that question had 2 answers when actually it only had 1? It was the one underneath it that had 2 answers. And we'll call that good. So last question. And that, after this one, we're perfect time to finish. It's quite a long one. It's question 16. And it is an application question. And let me show you what it is. That's probably the easiest way to do it. It's a kind of thing that you might have got or you might get in a physics class. If you do enough physics, I'm sure this will appear. Just try to kind of, there, got the question. What did you do that for? Come back. Right, I got the question again. And let's show you. You may or may not know this, but light gets bent in mediums. Right? It gets bent through the air, which is why you can see rainbows sometimes. It gets bent in the water. Have you ever seen the thing where you see a fish in the water, but actually where you see it is not where the fish is because the light has been bent? So people who actually catch fish, Native Americans and whatever catch fish, knew that. So if you try to spear a fish, you don't spear where you think it is. You spear where it really is, right? Because it gets false impression. Anyway, it's been observed for a long time that light bends, refracts or gets bent in a medium. So air into water, glass, and so on. This is the connection formula. The sine of angle θ1 over the sine of angle θ2 is the velocity of light in medium 1 and velocity of light in medium 2. So can you imagine we have air and the water, right? Light comes in at this angle called θ1, and that angle is measured from the vertical. but it gets bent a little bit and it now becomes theta 2. Now this thing here has a name and they call it, what do they call it? It's in here somewhere. It's called the index of refraction. And so it depends what it is. For instance, if it was water, this thing is 1.33. And if it's diamond, it's 2.41. I wonder if that's why diamonds sparkle. Right, the light gets refracted, and then it kind of bounces inside the crystal. And so you get a little sparkle. Anyway, it's a good enough guess. So we are going to do a story where we are given some information, and our job is to find out what theta 2 is. If the first angle, theta 1, is coming in at an angle of 70 degrees, our job is to find the angle theta 2. So that's me got all the stuff. Let's set up the working and solve it. Eventually, once I...
Did I have the velocities on there?
It didn't, it just told you the refractive index. Did it have the velocities? No, but you don't need to, because V1 divided by V2, the thing they call the refractive index, they just tell you what that fraction is instead.
Oh, gotcha. Okay.
So it makes your life a little bit easier, because speed of light is a very big number. You don't want to do calculations with it. And here we go. So I'll start with the physics formula. Do you know, if you know nothing about physics, but all you were told is that this was equal to 1.33, and then I told you what theta 1 is and asked you to find theta 2, wouldn't that be pretty much all you needed to know? You don't need to know the physics or anything. So the sine of 70 degrees divided by the sine of the angle I want to know, theta 2, is going to be 1.33. Okay, here's a clue to what I'm going to do next. What am I going to do next?
Cross multiply.
Okay, so 1.33 times the sine of theta 2 is going to be 1 times the sine of 70, which is just the sine of 70 degrees. Okay, what am I going to do now?
Divide by 1.33.
We're almost there. How will I find theta 2? What will I do next?
Take the inverse of sine.
And at that point, won't you just grab your calculator? So, should my calculator be in degrees or radians for this question?
Degrees.
So let's find out where it is. And it was in degrees, which is good. But you know, if I hadn't checked, wouldn't it probably be in radians? Because I didn't bother checking. That's Murphy's law, right? When you don't check is when you should. So inverse sine, sine of 70, divided by 1.33. And the answer I get is 44.9. What do they want it to? 2 decimal places, okay? So 44.95 degrees. You can now do physics. Can't you do questions involving light going from water to glass, water to diamonds, water to whatever they ask you for? Can you just tell me one of them and I'll tell you the other? So what was the difference? So it came in at 70 and it finished at, let's call that 45, right? So can you imagine, here is the water, there is that invisible dotted line, and it came in at an angle of 70. So 70 would be about that much, right? Maybe a bit steeper. And then it left at 45. So you would think, that's a fish, by the way. You would think that the fish was here, wouldn't you? But wouldn't the fish actually be there? Or vice versa, I'm not quite sure which one I've got. So if you were trying to spear a fish, if this is the right way around, wouldn't you spear where its tail was or just behind its tail to get it? Because if you tried it the other way, you might miss it. That's kind of sort of a cool, isn't it? Right. Did I tell you, since we're talking about fish then, did I tell you the joke about the sharks? Right, while you're saying your last name for attendance,